Hi students, today we are going to discuss about ordinary differential equations. Ordinary differential equations. First, let me explain what is differential equations. So what is differential equation? It is an equation. There is an equation which involves differentials or differential coefficients. Okay, so first we'll see higher order differential equations with constant coefficients. Okay, so there are two coefficients, one is constant, another one is variable coefficients. So how the general equation looks? So it is d power n y divided by dx power n plus k1 into d power n minus 1 into y divided by dx power n minus 1 plus k2 into d power n minus 2 into y divided by d power x dx in power n minus 2 and so on. At last you'll be having kn into y, which is equal to, the right hand side is some function, so that I'm going to write it as q of x. So in general, for easiest version, you can rewrite this d by dx as capital D. So if you rewrite this as capital D, then this equation becomes dn plus k1 into d power n minus 1 and so on plus kn into, take your y as a common term, into q of x. Okay, so here k1, k2 and kn are constant. So here k1, k2 till kn are constants. Okay. To find differential equations solution, okay. So to find the complete solution, so here we call it as complete solution. So what is complete solution? So this complete solution y is equal to CF plus PA. So I'll tell you what is CF. It is complementary function and this PI is particular integral. Okay, so there are three ways to find complementary function. It depends upon the roots, and there are certain ways to find the particular integrals if constant coefficient occurs. Okay, so we'll see one by one. So we'll see one by one. So first we'll see to find complementary function. Okay, so there are three cases. First case, if the roots are, okay, so from the auxiliary equation you will find the roots. Suppose if the roots are real and distinct, different one, okay, then this complementary function CF is A e power m1x plus B e power m2x, okay. And for case 2, so suppose second case, if the roots are real and equal, if the roots are real and equal, then CF is equal to A plus BX into e power mx. And case 3, if the roots are complex, so what do you mean by complex? It is in the form alpha plus or minus I beta, okay. So if the roots are complex, alpha plus or minus I beta form, then CF is equal to e power alpha x into A cos beta x plus B sin beta x. So there are 3 ways to find your complementary function. It depends upon the roots. The equations will vary. Okay, if the roots are real and distinct, then it is A e power m1x plus B e power m2x. The roots are real and equal, then it is A plus bx into e power mx. And the last one, if the roots are complex, that is in the form alpha plus or minus I beta, then that can be written as e power alpha x into A cos beta x plus B sin beta x. Okay, so after finding your complementary function, we need to find out particular integral. Okay, so to find particular integral, so Pi general form is nothing but 1 by f of d into q of x. I'll tell you what is this f of d. So f of d is nothing but this one. So this motion. So d power n plus k1 into d power n minus 1 plus and so on kn, right? So this portion can be considered as f of d and your right hand side is q of x. So what is a particular integral? In general, it is 1 by f of d into q of x. So there are 5 types to find particular integral for constant coefficients. Okay, so let me explain you the first type. So type 1. So what is type 1? If your q of x, that is your right hand side of the differential equation, is in the form of e power ax. So if the right hand side arises e power ax form, then replace d by f of a. Replace d by f of a. So which is nothing but pi is equal to 1 by f of a, that is replace d by f of a into q of x, that is e power ax. It is possible only if f of a is not equal to 0. So this is most important. Okay, since f of a is not equal to 0, we can directly write here p is equal to 1 by f of a into e power ax. Suppose if your f of a is equal to 0, okay, if f of a is equal to 0, then this can be written as x divided by f dash of a into e power ax. And again, if you are getting f dash of a is equal to 0, so what happens? Then this one becomes x square divided by f double dash of a into e power x and so on. So it goes like this. So your denominator should not be equal to 0 when you replace d by a. So that is most important. Okay, so this is your type 1. So type 1 is actually very easy. Your right hand side must be e power ax form. Then you have to replace d by f of d by a. It's not actually d by f of a, d by a. Okay, so now we'll move on to the problems. So first problem, first I'll take a simple problem. Solve d square plus 1 of y is equal to d square plus 1 of y is equal to e power minus x. So it is e power minus x. So to find the solution for this differential equation, first take your left hand side. So it is d square plus 1. So that d square plus 1 can be written as an auxiliary equation. So the auxiliary equation for this problem is m square plus 1 is equal to 0. Okay. Now you find the roots for this problem. So m square plus 1 is equal to 0. Then what is your root? F is equal to plus or minus I. Because it goes to the other side, it is minus 1. M square is equal to minus 1 means the root are plus or minus I. So now this is in the form of alpha plus or minus I beta. Here there is no alpha, so you consider it as 0 and beta is 1. Okay, so if it is a complex root, then your complementary function can be written as e power alpha x a into cos beta x plus b into sin beta x. So now this is 0, so e power 0 x and a cos beta is 1, so it is x, b sin x. So anything power 0 is 1. So what's your complementary function? A cos x plus b sin x. So this is your complementary function. Okay. So now we are going to find the particular integral. So what is the general form to find the PI? PI is equal to 1 by f of d into e power ax, because it is in e power ax form, so it is e power ax. Replace d by a. So first I'll write what is f of d. It is d square plus 1 into e power, what is the right hand side of the equation? E power minus x. So it is e power minus x. So what is your a here? A is equal to minus 1. So now if you put d square is equal to minus 1, what happens? That minus 1 becomes plus 1. So 1 plus 1 is 2 into e power minus x. Replace d by minus a. So d square is equal to minus 1. So this one becomes 1 by 2 e power minus x. So this is your PA, general PA. So what's your complete solution? Y is equal to CF plus PA. So what is your CF? A cos x plus B sin x plus e power minus x divided by 2. Okay, so this is how you have to find the complete solution of type 1. Okay, so next I'll do one more problem under type 1. So second problem. So second problem is d square minus 4d plus 4 of y is equal to 2 power x. Okay. So 2 power x. First we'll find out the complementary function. So to find the complementary function, you need auxiliary equation. So the auxiliary equation is m square minus 4m plus 4 is equal to 0. So what are the roots? M minus 2 into m minus 2 is equal to 0. So m is equal to 2 comma 2. See, the roots are real and equal. So what is your complementary function? It is a plus bx into e power mx. So it is m is equal to 2. So it is e power 2x. So to find complementary function, so to find pi. So to find pi, the general form of pi is 1 by f of d into q of x, right? So this is general formula. It is equal to, what is your 1 by f of d? So what is your f of d? F of d is d square minus 4d plus 4. Okay. So d square minus 4d plus 4 into 2 power x. Okay, so now this is not in the form of e power ax, but you have to bring it in the form of e power ax. So how will you bring it? This can be written as d square minus 4d plus 4. This 2 power x can be written as e power log into 2x. So e and log will get cancelled, then you'll be getting the 2 power x. And this equation does not affect your previous step. So you can rewrite that 2 power x as e power log into 2x. 2 power x. Okay. It is not 2 power x. 2x, 2 power x. So what is log a power m? So this can be written as m log a. So this is log property. So 1 divided by d square minus 4d plus 4. So this can be written as x e power x into log 2. Okay. So now we got the form e power ax. So what is your a? So a is equal to log 2. So what is the procedure? Replace d square by d place d by a. So this is the way to find if it in the form of e power ax. So what is your a now? It is log 2. So you just substitute your d square as log 2 square minus 4 into log 2 plus 2 into e power x log 2. So this is your PA. So what is your final solution? Complementary function plus particular integral. Okay. So this is another way. Next. So type 1 is clear now. We'll move on to type 2. If q of x, that is right hand side of your differential equation, is sin ax or cos ax. So if it is sin ax or cos ax, then replace d square by minus a square. Okay. So you have to replace only d square divided by minus a square. So we'll take the problem. So first problem, solve d square plus 4 of y is equal to cos 2x. Okay. So cos 2x. So we have found we found a complementary function in previous two problems, right? So here we'll find only PA. Okay. So to run the video, I'm going to find only PA. So PA is, to find PA, so what is the general formula? It is 1 by f of d into q of x. So it is 1 divided by d square plus 4 into cos 2x. So what is the condition? Replace d square by, what is your a? It is minus 2. So minus 2 square is minus 4. It is not minus 2 the whole square. So be very clear with that. D square by minus a square. So the minus is fixed. So now you substitute. So what happens? Minus 4 plus 4 into cos 2x. So what happens? This denominator becomes 0. So if the denominator becomes 0, your PA formula changed into like x divided by f dash of t into q of x. So x divided by, so what is your f dash of d? It is 2d into cos 2x. So now this is nothing but x by 2 into 1 by d into cos 2x. First I'll tell you what is d. D is equal to d by dx. So 1 by d is nothing but integral of dx. Okay. So capital just d is nothing but d by dx differentiation. If it is 1 by d, then you have to integrate this cos 2x into dx. Okay. So it is x by 2. So what is integration of cos x? It is sin x. So it is sin 2x divided by 2. So now this can be written as x sin 2x divided by 4. So now this is your PA. Okay. Next problem. Or we'll move on to type 3. So type 3 is nothing but if your q of x is a polynomial form. Okay, so directly I'll move on to the problem. So first problem, solve d square plus 1 of y is equal to x square. So what is your auxiliary equation? So auxiliary equation is m square plus 1 is equal to 0, then m is equal to plus or minus I. So we have already found this. So what is your complementary function? A cos x plus b sin x, since alpha is equal to 0 and beta is equal to 1. Okay. So again write your general PI formula. So general PI is 1 divided by f of d into q of x. So what is your f of d? It is d square plus 1 into x square. So x square. So how will you solve this problem? So to solve, how to solve this polynomial form? You rewrite this equation as 1 plus d square the whole power minus 1 into x square. So now what is 1 plus x the whole power minus 1? It is 1 minus x plus x square minus and so on. Okay. So similarly, this can be written as 1 minus d square plus d square the whole square minus and so on into x square. So now you multiply. So before multiplying, find out what is d of x square. So what is d of x square? Differentiation of x square. It is 2x and d square of x square. That is, this is d power 1 of x square. Next d square of x square. So what is d square of x square? it is 2, and d cube of x square is 0. So till 0, you find the derivatives, and then it is very easy to expand the previous equation. So now you multiply this entire bracket with x square. So 1 into x square is x square, and then minus d square into x square. So next one is d power 4 into x square, and so on. Since d cube of x square itself 0, then this portion becomes 0. So what's your answer? X square minus, so d square of x square is 2. So P8 for this problem is x square minus 2. So what's your final solution? A cos x plus b sin x plus x square minus 2. So these are the 3 important types to find the particular integral for constant coefficients. So what's your type 1? If your right hand side of the differential equation is e power ax form, then replace your d by f of d by a. Okay. Similarly, second type is if your right hand side is sin ax or cos ax, then replace d square by minus a square. And third type is just a polynomial. Suppose this polynomials may be x square plus x plus 1, and also x cube plus x square, 4x minus 2. So these types of polynomials occurs on the right hand side. So for this type, you have to use the binomial expansions. So there are so many binomial expansions, 1 plus x the whole power minus 1, and then 1 minus x the whole power minus 1, and also you can write this 1 plus x the whole power minus 2, 1 minus x the whole power minus 2, and so on. Okay. So you expand this binomial expansion and then multiply with your polynomial. So before multiplying, find your derivatives of the polynomial till it gets 0. Okay. Then it is easy to cut short your expansion. Okay. After finding that expansion, and you can combine your complementary function plus particular integral. Thank you. Hi, dear students. Today we are going to discuss about Gram-Smith orthogonalization process. So it is Gram-Smith orthogonalization process. Okay. So first we'll see the applications where it applies. It mainly applies in machine learning. And then QR decomposition, signal processing. So these are the engineering streams where we can apply Gram-Smith orthogonalization process. And also it helps in scientific computing. It also helps in scientific computing. So before going to this Gram-Smith process, let me tell you what is orthogonal vectors. So orthogonal vectors. So it's simply if you satisfy u dot v is equal to 0. So this is dot product. So if u dot v is equal to 0, then these two vectors are orthogonal to each other. So here we are going to use inner product. So this dot product can also be written as inner product. If the inner product of u comma v is equal to 0, then u and v are orthogonal to each other. In our Euclidean space, it is also called as dot product. So first we are going to solve one problem. So before moving on to the problem, so we are going to find two things. One is orthogonal basis and orthonormal basis. So let me write the formula first for orthogonal basis. To find orthogonal basis, there are three steps. So first step is U1 is equal to V1. So which is, what is V1? That is actually equal to U1, first orthogonal vector. And then to find the second one, it's U2. So the formula is V2 minus inner product of V2 comma U1, the whole divided by inner product of U1 comma U1 into U1. So this is the next formula to find the U2. And then step 3, so the last vector, to find U3, the formula is V3 minus inner product of V3 comma U1, the whole divided by inner product of U1 comma U1 into U1, and one more term, that is minus inner product of V3 comma U2 divided by inner product of U2 comma U2 into U2. So these are the three steps to find orthogonal vectors. And to find orthonormal basis, so we consider it as W1, so which is nothing but U1 divided by norm U1, and then W2 is equal to U2 divided by norm U2. Similarly, W3 is equal to U3 divided by norm U3. So these are the formulas to find orthogonal basis and orthonormal basis. So today we are going to discuss one problem manually. Today we are going to solve one problem manually, and also I'm going to solve the same problem using MATLAB. Okay, so I'll explain what is MATLAB in the next half an hour. So first we'll see the problem. So problem 1, apply Gram-Smith process. The question will be like this: apply Gram-Smith process to construct an orthogonal basis and orthonormal basis. Set of vectors V1, V2 and V3, where V1 is equal to, say for example, 1, 0, 1, and for V2 it is 1, 3, 1, and then for V3 it is 3, 2, 1. Okay, so for these three vectors we are going to find orthogonal basis and orthonormal basis. Okay, so next, first we'll find orthogonal basis. To find orthogonal basis, and we have the formula already, so we'll do step by step. So first is step 1. So we know that step 1 is actually U1 is equal to V1. The first orthogonal vector is simply the first given vector. Okay. So next, so what is the answer? U1 is equal to, it is 1 comma 0 comma 1, which is nothing but V1. So the step 1 is actually very easy. And then step 2. So step 2 is U2 is equal to, once again I am repeating the formula, it is V2 minus inner product of V2 comma U1 divided by inner product of U1 comma U1 into U1. Okay. So first you fix everything in this formula. So what is that? U2 is equal to, what is V2? It is 1 comma 3 comma 1 minus inner product of V2. So again V2 is 1 comma 3 comma 1 comma U1 is 1 comma 0 comma 1. The whole divided by inner product of U1 comma U1. So what is U1? It is 1 comma 0 comma 1 and then 1 comma 0 comma 1 into U1. So what is U1? It is 1 comma 0 comma 1. So we have already discussed about inner products. If not, I'll tell you one more time. So what is inner product of U comma V? In general, this can be written as U1 plus V1 plus U2 plus V2 and then plus U3 into V3. So in this step, we'll solve one by one. So first take your numerator, inner product of 1 comma 3 comma 1 comma 1 comma 0 comma 1. So use this formula to find the inner product. So what is your U1? So this is actually U1, U2, U3 and then V1, V2, V3. So now you apply this previous formula. So it is 1 into 1 plus 3 into 0 and then 1 into 1. So what is the answer? 1 into 1 is 1 and then 3 times of 0 is 0. 1 time of 1 is 1. So 1 plus 1 is 2. So the numerator of that portion is 2. Similarly, second one is inner product of 1 comma 0 comma 1 comma 1 comma 0 comma 1. So this is actually nothing but same vectors. So you can square the terms. So it is 1 square plus 0 square plus 1 square. And then this is again equal to 0. Okay. So now you can substitute in this V2. So in this V2 you can substitute U2, sorry. So U2 is equal to 1 comma 3 comma 1 minus, and you know what is that inner product of 1 comma 3 comma 1 comma 1 comma 0 comma 1. So the answer is 2 divided by, the numerator portion is also 2 into 1 comma 0 comma 1. So when you simplify this, what happens? This 2 and 2 will get cancelled and then the remaining portion is 1 comma 3 comma 1 minus 1 comma 0 comma 1. 1 comma 0 comma 1. So if you simplify this, just to subtract the terms. So 1 minus 1 is 0. 3 minus 0 is 3 and then 1 minus 0 is 1. So what is your U2? U2 is equal to 0 comma 3 comma 0. Okay. So next we'll move on to step 3. So step 3 is to find U3. So what is the formula? V3 minus inner product of V3 comma U1 divided by inner product of U1 comma U1 into U1 minus inner product of V3 comma U2 divided by inner product of u2 comma u2 into u2. Okay. So we'll find one by one. Wait one second. So it is inner product of v3 comma u1. Okay. So what is v3? What is v3? v3 is actually 3 comma 2 comma 1. So it is 3 comma 2 comma 1 minus inner product of 3 comma 2 comma 1 comma 1 comma 0 comma 1, the whole divided by inner product of 1 comma 0 comma 1, and then it is 1 comma 0 comma 1 into u1 is 1 comma 0 comma 1. So next one is, last term is inner product of again 3 comma 2 comma 1 comma u2. So what is u2? u2 is 0 comma 3 comma 0. So we found that only. So it is 0 comma 3 comma 0. Close the bracket and then whole divided by inner product of u2 is 0 comma 3 comma 0 and then 0 comma 3 comma 0 into u2 is 0 comma 3 comma 0. So we'll find one by one inner product of 3 comma 2 comma 1 comma 1 comma 0 comma 1. So what is the formula? You just multiply the terms individually and then add it. That's all. So it is 3 times of 1 plus 2 times of 0 and then 1 times of 1, which is actually equal to 4. And we have already found inner product of u1 comma u1, right? So the answer is 2. So it is in the previous step. So next we'll find inner product of 3 comma 2 comma 1 and then 0 comma 3 comma 0. Okay. So now if you simplify this, it is 3 times of 0 and then 2 times of 3 plus 1 times of 0. So the answer is 6. Okay. So next we have to find inner product of u2 comma u2, right? So you just square the number. So what is inner product of u2 comma u2? It is 0 comma 3 comma 0 and then 0 comma 3 comma 0. So the answer is actually 0 square plus 3 square plus 0 square. So the answer is 9. Okay. So now we found everything and we'll substitute. So what happens? That u3 is equal to v3. So what is your v3? This 3 comma 2 comma 1 minus the numerator is 4 and the denominator is 2 and your u1 is 1 comma 0 comma 1 minus 6 by 9 into 0 comma 3 comma 0. Okay, so simplify this. It is 2 2s are 4 and this one is 2 3s are 6 and then 3 3s are 9. So what happens? It is 3 comma 2 comma 1. Now you multiply this with your numerator. So it is 2 into 2 comma 0 comma 2. And what happens? This is actually 2 by 3. So 2 by 3 times of 0 comma 3 comma 0. So since it is a fraction, multiply by 3. So what happens? The numerator 3 and denominator 3 will get cancelled. So the answer becomes, what happens? It is 0 comma 2 by 3 is actually 3 will get cancelled. So it is 2 and then 0. So now you subtract it each terms. So the answer is 1, comma 0, comma minus 1. So this is your U3. So you can check it. 3 minus 2 is 1. So 1 minus 0 is 1. And then 2 minus 0, it is 2. Minus 2, it is 0. And then 1 minus 2. So this is actually 1 minus 2. 1 minus 2 is minus 1. And then minus 0. So it is minus 1. So U1, U2, U3. So now you have to check the orthogonality. So orthogonality is nothing but U1 dot U2 is equal to 0. And then U2 dot U3 is equal to 0. Similarly, U3 dot U1 is equal to 0. If you check these conditions, then your answer is correct. So this is the way to check your answer. U1 dot U2 is equal to 0. U2 dot U3 is equal to 0. And then U3 dot U1 is equal to 0. So next we'll find orthonormal vectors. So to find orthonormal vectors. Okay. So we have already written the formula. First we'll find U1, that is W1 is equal to U1 divided by norm U1. So what is your U1? 1, comma 0, comma 1. This norm U1. So what is norm U1? Which is nothing but square root of inner product of U1, comma U1. So this is actually norm U1. So inner product of U1, comma U1, you already know. This is U1. Suppose 1, comma 0, comma 1. And then 1, comma 0, comma 1. We have already found the answer. It is 2. So what is norm of U1? Is what is norm of U1? It is root 2. Similarly, W2 is equal to U2 divided by norm U2. So U2. So what is your U2? U2 is, we have already found U2. So what is U2? U2 is 0, comma 3, comma 0. Okay. So it is 0, comma 3, comma 0 divided by inner product of inner product of 0, comma 3, comma 0, 0, comma 3, comma 0. So this is also we have already found. It is 9. So it is 9. 0, comma 3, comma 0 divided by root 9. So it is 0, comma 3, comma 0 divided by root 9 is 3. So if you simplify this, 0, comma 1, comma 0 is your W2. Okay. And then what is W3? So W3 is U3 divided by norm U3. First you take what is U3. U3 is 1, 0, minus 1. So 1, 0, minus 1 into norm of 1, 0, minus 1. So what is norm of 1, 0, minus 1? It is 1, 0, minus 1, which is nothing but root 2, because 1 square plus 1 square is 2, and then it is root 2. So the answer is 1 by root 2, 0, minus 1 by root 2. So these are the orthonormal bases. So next, so that's all. The solution is over. So now I'm going to solve the same problem using MATLAB. So there are many ways to check your mathematical calculations, but you can do only addition, subtraction, multiplication, square root, and matrix additions. Some of the advanced techniques you can use your calculators to check the answers. Okay, but this one is actually very useful to find the exact mathematical derivations, and you can see the pictorial representations also. So what is MATLAB? So this is actually matrix laboratory. This is matrix laboratory, or you can call it as matrix lab. Okay. Matrix lab. So in this matrix, I'm going to solve the same problem to check whether the orthogonal basis and the orthonormal basis are correct. And also we'll see how to find the eigenvalues, eigenvectors, rank of a 3 by 3 matrix using MATLAB. Okay, so I'm closing this whiteboard and we'll move on to MATLAB portion. So this is your MATLAB screen. This is actually online MATLAB screen. You can see this window, the upper portion. So this upper portion, can you see this? I'm maximizing this portion. The numerator, the first one is editorial window. So in this editorial window, you can save all your contents. See, I have so many folders. So here I have already saved one folder, that is linear algebra. So first I'll show you how to run the program and how to write the coding for this Gram-Smith process, Gram-Smith orthogonalization process. So whenever you are opening a command window, first you have to press CLC. That is nothing but it will clear your previous content. So CLC, and then matrix formation. So here you can see the matrix formation. I have already stored in this. So it is A is equal to 1, 1, 3, and then 0, 3, 2. Last one is 1, 1, 1. So I have taken different method, different matrix to find the orthogonal basis and orthonormal basis. So to display this matrix, you have to write display matrix A, display A. Okay, so this semicolon, if you put this semicolon, then that code will not run. So it is matrix A is equal to 1, 1, 3, 0, 3, 2, and then last row is 1, 0, 3. So what is rank of a matrix? So rank of a matrix is nothing but R is equal to rank of A. So I have already mentioned the matrix A is 1, 1, 3, 0, 3, 2 and 1, 1, 1. So if you put semicolon, then it won't run the code. Next code is display rank of a matrix and display of R. So the rank of this matrix is 3. So for this problem, rank of a matrix is 3. So MATLAB gives you the direct answers. You can cross check with your manual computation. So to find eigenvalues and eigenvectors, so this is your code. B comma D is equal to EIG is nothing but eigen of A, matrix A, and display the eigenvectors. So see, so these are your eigenvectors. It is in decimal values, and also you can find the eigenvalues. So display eigenvalues. So these are the eigenvalues 0.8558, 1.6784, 4.1774. So these are the eigenvalues. Next, we'll move on to the Gram-Smith process. Okay. So we have already solved the problem manually. Now we are going to solve the same problem using MATLAB. So first vector V1. So define your V1 is equal to, open a close bracket, 1 semicolon 0 semicolon 1, then close the bracket. Put a semicolon, then it won't run. Next vector is V2. After these two arrow marks only, you can enter the next line. So V2 is equal to close bracket 1 semicolon 3 semicolon 1, close the bracket, put a semicolon, and then V3. So wait for the double arrow. Next V3 is equal to, open a bracket, 3 semicolon 2 semicolon 1, and then close the bracket, put a semicolon. So we have feeded V1, V2, V3. So now we are going to give the formula. So the first, what is the first step? U1 is equal to V1. So MATLAB reads your U1 is equal to V1. And similarly, U2 is equal to V2 minus, so I have already told you what is inner product of V2 comma U1. It is nothing but dot product of V2 comma U1. So MATLAB takes only dot product. So you open a bracket, dot, open a bracket, V2 comma U1. So which is nothing but dot product of V2 comma U1. It is also called as inner product of V2 comma U1 divided by dot product of U1 comma U1. So it is again nothing but inner product of U1 comma U1, close the bracket, into, so for multiplication you have to use this star symbol and then multiplied by U1, put a semicolon. Okay, so this is your second orthogonal vector. So wait for the double arrow. Now you can write U3. So what is your U3 formula? It is V3 minus, open a bracket, dot product of, so what is your third formula? Dot product of, I have already stored this formula. So we'll take the same formula, V3 comma U1, which is nothing but inner product of V3 comma U1, and then divided by inner product of U1 comma U1. Next, minus dot product of V3 comma U2 till U2. So which is nothing but inner product of V3 comma U2 divided by inner product of U2 comma U2 into 2. Put a semicolon. So we have feeded 3 orthogonal basis formula. Now we'll ask for the answers. So display orthogonal basis. So it will show you the answers. So check your answers. See this 1, 0, 1, 0, 3, 0, 1, 0, minus 1. So these are the answers. We have already manually solved this problem. So these are the orthogonal basis. Next, orthonormal basis. So what is your orthonormal basis? Here they are representing E1, but we have already taken W1. So you take it as W1. W1 is equal to U1 divided by norm of U1. So use the formula norm of U1. and then put a semicolon divided by W2 is equal to U2 divided by norm of U2. Put a semicolon and then W3 is equal to U3 divided by norm of U3. Okay. So display ortho normal basis. So here we have changed that E1 as W1. So you change it as W1, W2, W3. So display orthonormal basis. So if you check, so we'll wait for the answer. See, it is in decimal number, but if you take it in a fraction manner, then you can attain that fraction values 0.7071, which is nothing but 1 by root 2. Similarly, second orthonormal basis is 010 that we are getting actually, and the last one is 0.7071, 0 minus 0.7071. So this is the easiest way to check your problem is correct or wrong using MATLAB. So the MATLAB is actually very user friendly to attain any kind of mathematical problems. So these are the basic codings to get the orthogonal basis and orthonormal basis using Gram-Smith process. Okay. To check the verification part, so I have already told you to check the verification. So take the dot product of U1, U2. The answer must be 0. If the answer is 0, then your answers are correct. Orthogonal bases are correct. So to check the verification, so use this code display of dot products. So dot product is U1 comma U2 and then U2 comma U3. Similarly, you have to check it for all the three vectors. So I am putting here, it is display of W1, W2. So sorry, I didn't copy that. So display dot product of U1 comma U2, U1 comma U3, and then last one is U2 comma U3. So the answer must be 0. So if all the answers are 0, then it attains the orthogonality. Okay. I hope you can understand this problem manually and also in MATLAB. So MATLAB is the easiest tool to verify your answers are correct or not. Okay. So thank you, students.